when we left off with this yesterday, we had the LCD hooked up and powered the machine on, and essentially it shuts down after a few seconds. For a moment, I was thinking, well, for a while, the whole episode, I was thinking this AMD chip might have had something to do with it. But after sleeping on it, these are not the same symptoms as like the Xbox and the old iMacs, where you'd have to, heat up those boards, try to get them to adhere better. This video is clearly initializing, so a little unfair to the AMD. We've had our past, but I think that that is definitely the wrong avenue at this point. It also occurred to me, right off the bat, as soon as we saw it, it's like, hey, this looks like a thermal shutdown. It also dawned on me, I'm not seeing these fans turn at all, and you would think if the machine were to be detecting any sort of anomaly with the temperature, the fans would at least try to cool it off. Also found out these Pentium 4 mobiles, their thermal shutdown is actually built into the CPU, has no interaction with the BIOS, so the CPU controls it. If it gets too hot, it simply turns off, shuts down the system. So I think that's what's going on here, and the reason I said in the title here that this will be the final is we're going to do some more testing here. I'm going to get some thermal paste. I'm going to test these fans here in a moment. But the best thing that I think I need to do is going to be to try a known good CPU here. I do not have one, and I don't have the schematics for this board, so not ruling this out before starting much more intricate probing, which is probably past my skill set right now. The best thing to do is wait until I get a replacement, try out another CPU, and go from there if we don't find something going on during this setup. All right, so just as a reminder, plug the machine in. I took the LCD and cover off. We don't need these anymore. For one, I don't think that keyboard's any good. It never responded, but a USB keyboard responds. So even after solving the power problem, I think, we're not done yet. And I don't need a mouse or anything right now. I just need this machine to post long enough to show that it's doing anything. Before I pull this out and breadboard it again, I'm going to go through a couple of things and do the thermal paste and all that. So we go to turn it on. See here, everything looks normal on power. Monitor comes on. Comes up here. I know this is hard to see. I'm going to solve this in the future with, I'm just going to have a digital pass through for my VGA connections, and not worry about this camera setup because this just doesn't work. But until then, you can see that it's just sitting here waiting on post. And there you go. So after just sitting and letting it wait, I went to grab the keyboard to go into setup. It shuts down. You can see here, the machine is still drawing current. Oh, I actually think it rebooted it. It may have rebooted. So it's going into some sort of loop at this point, and for sure we're already pretty toasty. So we're going to keep exploring this and this. But as you can see, these fans aren't turning. And I don't recall ever seeing them turn. I think they should turn on as soon as the power comes on. Just like most laptops, but again, nothing. So maybe we got some thermal management problems, period, and that's all that's going on here. The CPU just shuts off when it detects that it's too hot, and then whatever the motherboard has going on is not currently doing what it's supposed to be doing, I don't think. So again, I think this is the wrong avenue. I'm glad we kind of, I didn't rage quit. I was close to rage quitting, but I'm glad we had a break anyway. I'm going to do some more probing, and we're just going to go from there. So first thing, we're going to turn this off. Let's see if these fans even work. Well, just this one. I'm only going to test this one. So let me unplug this. This is a 5-volt fan. Reset the power supply here for a second. Here's my other probe. Alright, so let's set the power supply for 5-volt. Oh. Five volts, this thing only is rated for 0.22 amp. We're just going to set this. I'll give it a little bit more and see if it tries to pull more, but oh, damn it. It gets a proper, better way of doing this in the future. This connector is tiny. Alright. Five volts going in. Spun right up, and it's pulling exactly what it's supposed to pull. Like it's dead on. So we have a good fan, and it sounds great too. It's a shame that it doesn't spin up. Alright. So fan is good. I could check to see if this is trying to do. Let's see what kind of voltage we're getting on this connector when we power it. Oh, you know what? Crap. We'll go ahead and reset this. Where are my leads? Oh, this is not a how-to, and I'm not an expert. I know some things. So if you're watching and you're like, oh, what should I do with my bench power supply? I'm not the right guy to ask. Like, I have some basic understanding here. This gives me DC voltage at a very consistent rate. Like, it's easy to work with, but you can absolutely hurt yourself and equipment, even with just a laptop. So, you know, not a how-to. Anyway, so we are back to being plugged in. So let's go ahead and reset our power supply. $16.5. And then I'll set this back to. Here we go. Oh, we got it. Oh, I thought we had a short. Alright, so let's see what we get from this fan connector. Let me just find, let's get around here. Power on. So far, nothing. It's already restarted. It's like if there's sensors on this board, which I have no idea if there is, Panasonic, you know, there's no documentation, and I haven't found anything that looks like a sensor yet. not that I was really looking, but if it was detecting the amount of heat that the processor is, it would be turning this fan on, and it's not even sending power to it. So, you know, that's just another clue. But before I start going wild trying to test something that I don't have 100% knowledge of, I really want to get another Pentium 4 compatible with this to test it out. Alright, so that's plugged back in. Obviously, no change. It's still in its boot loop, or shutting down and rebooting. That heatsink's getting incredibly hot, of course. So we're going to go ahead and get some thermal paste in here. Get some debris. Sorry about that. Things had to get changed. Hopefully that'll be much better in the future. But all right, let's take this heatsink off real quick. Told you that would melt again, but anyway, let's put some fresh stuff on here. I don't think this is going to solve it. It may give the processor a few more seconds, but we're gonna see. It's worth a shot at least. And if it does fix it, that means that these run at an incredibly high temperature, or something still might be wrong with this chip. So trying to get that into the fan. On these older processors, I tend to go a little heavy, and in the case of this Pentium 4, it really does run incredibly hot. Then I may even do some polishing here. But for now, I'm just gonna let gravity, you know, kind of take this excess out here. There's plenty of space on the heatsink, so I don't have to worry about anything like gobbing up or shorting out. And I can just get what I know is now a clean thermal interface. And then when you put these back on, you need to you know, depending on the number of screws, you're going to want to change the torque to come down evenly on the processor. So you're going to use, and here I only have 3 points, so I'm just kind of just going around like this, and as it starts to make contact, you know, it's going to start getting tighter and tighter, and that's where you're going to start bringing all these in nice and tight. That one just barely bottomed out, so I think we're just about good here. There we go. Alright, well, much much better thermal paste than it's ever had on it, I'm sure. Alright, let's see. Alright, screen is up. Still no fan action. Now we wait. Yeah. Back into the loop. Alright, let's see if I can see what's feeding this fan. I guess we'll kind of start here. Look at my old man eyes. So we got a small capacitor there. No, it's got to be for that connector probably. I do see not a whole lot, so not sure where this is running. Oh, no, there's two small caps, so we'll check those. One of those is probably for the fan, the other one for the connector. I'm going to recheck these MOSFETs over here. See if I can figure out where. So the fan is 5 volt. So perhaps there's a breakdown in the 5 volt circuit somewhere. So let's try to figure out where the 5 volt's coming out from and making sure we're receiving it. And I think this little bit of corrosion, this was just happenstance, almost certainly. I think that this reboot loop has probably always been the problem with this. And this is either just from sitting or, you know, a little bit of damage that it took while being handled at some point. So I don't think that this was the problem, or this was the problem. I think that it's always been this. And before, either I find schematics for this board, or I find a Pentium 4 1.6 or 1.4 to 1.6 gigahertz that is compatible with this, and test out that first. Because I'll be rage quitting this over and over, and I don't want to do that. Not to mention there's much more potential to make it worse. Well, let's see if we can figure out where 5 volt is coming from, and I guess go from there. Oh, I know. I'm gonna check the main rails coming in and make sure that I'm actually getting clean voltage first and foremost. And I still don't. I don't want to take this thing out. I don't remember where that damn cap was. Now I'm gonna have to find it again. Although it seemed like it was pretty obvious. That's a 3.3. That's odd. Oh, that's right. I'm in standby mode. These may not be hot yet. So we got at least one that's hot. Let's see what's coming out of these. Number 1, 3.3, 3.3. Trying to see that stupid dot. Oh, I have a different microphone. Does it sound better today? I think we got at least one bad MOSFET. One of these drain pins is dead. That's on 3.3 volt, but that could be operating relays. This one looks okay. I don't know how I missed that yesterday. Oh, there it is. Okay. Yeah. Two more dead drains. Let's see what happens when I switch it on. But I mean, I'm pretty sure if the gate is energized, then all four of those legs. Which side is the gate? Yeah, and this one's. Let's see here. So. Alright, so let's check this leg again. Yeah, nothing. So we got at least one. This one was good. Getting 3.3, 0, 3.3. Oh, you know what? I should probably put the zone meter in the frame so y'all can see what the hell's happening here. Okay, so here's what we have on these MOSFETs. On, what is it, IC54. Dead. 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 Oh. Oh, this one was giving me 3.3 earlier. Let's see. Something changed over here. Alright, we are struggling. Again, I don't know how I missed this yesterday. Oh, you know what? I'm an idiot. Let me try again here. Alright. There we go. So, 3.3 on IC54. Then some dead legs. Dead leg. Dead. And a 3.3 there. This capacitor is receiving 3.3. Pretty sure I should be getting 3.3. Okay. So we've got a bad cap already. Yeah, so this has got to be that. That's got to be power damage. Alright, so that's what's coming in. Oop. Might get some magic smoke. Oh, now it's trying to boot from network card. That was funny. That's the furthest that it's actually booted. 0.3. That seems like very little. That can't be right. $16 on this side. The second what? Oh yeah, the one over here. But I see we got power problems well before then, and like I said, I don't know how I missed it. So, right at the start of the circuit, so we have just a small capacitor. Got 16.3 on one side, and then it's only putting out, well, either goose eggs or, you know, well below what it should be. And like that's right at the start of this power branch, so man, she toasty. All right. This thing's hot as hell. What I think is happening, well, for sure, we've got a bad capacitor, at least two bad capacitors that I can measure. And I somehow didn't detect them yesterday. So I think I'm going to start with probably just removing them and see if there's improvement on the rest here, and then see if I get clean readings further down. Oh, and I missed one in here. Let me check that one real quick. Although this thing is super. Yeah, that should be good enough. Hi, Cyrus. We're definitely getting 5 volt from somewhere, so that's encouraging. You know, I'm saying there's no way this resistor would normally be gating this much current. And you know what's really funny is, what was it, the very first stream, I definitely hit this with the infrared. It's like, oh, there's a silly little resistor, but it looks like it might be in, you know, the temperature looked normal. You know, it's just a couple degrees warmer, but I don't think this is supposed to be resisting this hard. Let's see if I can see the number on this. Sorry about that, I'll fix the other camera in a second. So that is a 562. Oh, that was weird. Oh, and y'all didn't even get to see it. Alright, sorry about that. Alright, so before I knocked when I knocked the camera off, just sitting here, this fan definitely started to move a little bit. Now I got it set back up. Right now I'm just probing around these resistors. I got one here that seems to be resisting a whole lot, so I'm going to try to find a similar one and check its resistance, or the same one really. And I need to fix this janky setup for my next stream, but I will. So what did I say it was, a 552? Five, 6, 2. Now these resistor packs are 560s. Let's see what we get here. I mean, obviously these are a little beefier. You see through there, we're getting way more voltage. Still not seeing a 1-to-1. That's what I really want. What do you think, Lauren? Is a resistor capable, a tiny resistor, going from 16.5 volts to roughly 0.03. I'm saying not likely. So, although when I saw sparks earlier, maybe I burned this myself. That would be funny. What I could do, let me just bridge it. Do it all. Oh, it's not gonna like that. All right. So before I destroy everything, okay. I don't think I exploded anything. I'm pretty sure this resistor is absolutely dead. So let me pop that off. Let me find a donor board. I don't think I have. Like, I don't have these components, so this is annoying. Can I just bridge that, or is it? Let's see here. Oh, see? Fan did it again. Tried to spin. Ow, fuck. Hi. So at some point, and this leads me back to the CPU. I think that the internal management is shutting this thing down. I'm almost certain of it. And this, it seems like now the heat has gotten to the board and it's starting to spin up fans. But after it goes into the power loop, it really doesn't matter. Nothing's working the way it should. I think I have a bad resistor, and that's where I'm going to start now. I thought I had some bad caps, but after probing around a little bit more, I'm not so sure there's anything to worry about these caps. But this resistor is definitely holding this. It's 552. Yeah, I would definitely appreciate the value, but I think at the very least I've got a dead resistor here. But trying to spin this, so something definitely signaled to turn the fan on. So that's probably good news. And then I had 5 volt over here. That would be really funny if it was absolutely, yeah. The resistor is 552 or 562. I'm sorry. But I definitely saw that in the thermal cam. There's only 2-degree difference, and that felt pretty normal. But now I don't think it is. All right. And before I do any more laptops on the live stream, I need to get a better magnification system for everybody because I can't see up close, and this, even with the magnifying glass, is not sufficient for a lot of this work. So I need to find a better method for myself because I'm blind, and I'm sure it would be much more interesting to see a little closer to what I can see for sure. So I'm gonna try to find something that's, you know, very budget friendly, or maybe even rig something up that I already have. But for now, I'm gonna try to replace this resistor as soon as I can figure out the value. And if that doesn't do it, I think that is a stopping point on this machine until I get a Pentium 4 that is compatible with it. And then I will resurrect this project. Because again, there's no schematics, so all right. Okay, so I have a solution, I think. So 5.6, so it just straight is 562 kilo ohms. These legs might be way too big to try this, but I think it's worth a go. Oh, 562. What am I doing? All I have is a 470 and a 1 mega ohm. Worst case, I think smaller will just fry immediately. And I'm gonna find my box of donor boards. Let me see if I can find an exact match first before I do this. because I don't think this is close enough. Let me see. Not looking good to start. And this is before those components times. Well, some of them maybe. Just check this again, make sure I'm not being dumb. It's so hard to see. All right, 562. Yeah, fortunately, I don't have a lot of donor equipment yet. All I have is stuff that I haven't even tested yet. So I don't want to go down that rabbit hole. I mean, this project's going to end up, well, I mean, a resistor replacement's not hard. So I got a 503K here. That's a lot closer. I think that is worth a go. Yeah, you see, I'm not trying to do that kind of math. I am working with the VA. I may do some a program where I'm gonna try to get some more electronics, like hands-on training. But there's no way I can learn that math on my own. So you can spout off them numbers all you want, but I can tell you how that's gonna end up. What do you think about putting a 506K in its place? Like, I don't even know what this resistor is. Yeah, I kind of have to like visualize the numbers in 3D space, and calculators don't do that. So I don't know what the numbers are doing, and just what you wrote there, 3-digit code is first two numbers times 10, the third number. In this case, like, for one, how do you know if it's supposed to be squared or not? See what it's saying? Like, I don't know. That's not a strong point of mine. And likely never will be. Yeah, I think it's close enough that I shouldn't like have explosive like problems. Yeah, you know what? Got enough for government work. So we're gonna try this one resistor, and then I'm gonna cut the stream here. I'm sure I'll acquire the proper part. I'm not worried about that. But this needs to be checked out if this doesn't solve it, or if this resistor doesn't solve it. And I think that's the only component that doesn't look right to me at this point. You know, it virtually dead. So I think it is dead. Okay, yeah, let me check. Yeah, let's see if we get anything. I don't like testing in board, but it is right at the start of the circuit, so maybe we'll have that going for it. All right, what do you make of that? So obviously, a capacitor is in play over here, so I'm not getting a clean reading. Let me try change the polarity, but I don't think it's going to change anything. Yeah, I think I'm going to have to take it out of circuit. It was going to be coming out anyway, so it doesn't really matter. Alright, this is where I struggle with not damaging everything. Oh. I'm just going to try to get some flux on here, and I'm just going to slide it off the pad. That's the plan. And grab it with the tweezers. We'll see if the solder gods have that in my future. are you not letting go? There it is. I'm trying to get a little more heat in here because this is, there's some very large planes right under these components, so it's just sucking up all this heat. Let's try not to remove every component. Son of a bitch. Okay, that did not go as planned, so that might have been destroyed. Give me a second. Survey says. Oh, okay. It's not great. I did put flux on it. It wasn't let go, but then when I got it with the more solder, all right, that should be testable. Oh, there we go. Got it pinned. .8 kilo ohm. So that is absolutely not in spec. Unless you lied to me about these numbers. Okay. I think I'll get lucky since this isn't grounded. Hopefully. Where did it go? There it is. .68 kilo ohms. Again, end circuit. Okay, well that actually says, looks like 583. Yeah, I have no idea at this point, but this one on here, the one I was looking at, looks more like a 583. So I don't know what's going on. Where'd it go? When I put it under the heavy magnification, it has it's underlined. It says 683 or 603 with the writing messed up. It's no idea. Just try it. Yeah, let's see if I can get it off. Or I give it some. Yeah, I'm gonna lose this if I try to test it. I'm just dropping it in. All right, out of spec resistor is in place. Let's see if we get the puff of smoke. But at the end of the day, this is actually the last troubleshooting step that I can do because I do not have a cache of these resistors. So what I'll do, if this doesn't yield any improvement or just gives me a little puff of smoke, I'm gonna obviously locate the correct component here, and then I'm gonna keep looking for a P4M compatible with this board, because I think you know, if work in this area doesn't solve it, I think it's gonna come down to this chip. So anyway, so the moment of truth. Let's go ahead. All right, well, we'll say not the moment of truth, the moment of more information. Either in the form of puff of smoke, or no change, or whatevs. All right, going hot. All right, in standby mode, we are stable. Power on. Alright, so things are looking about the same as far as boot up here. Still no fan action. This didn't blow up, so I think, you know, that's a small win. Let's see if we can get into the BIOS. We can. Oh, maybe not. That might be it. Yep, sure enough. So, but let's see what the voltage looks like coming out of it now. I have to imagine it looks a lot more normal. Oh. Auto sensing does not mean auto detect AC/DC. Now we're, you know, that is a change. Now we're up to 0.335 voltage. See if anything changed down here. 3.3, 3.3. Goose eggs. Goose eggs. Goose eggs. 3.3. Yeah, I mean, what are the likelihoods, like, maybe I'm testing these wrong and I'm being stupid. I'm pretty sure these MOSFETs should all Yeah, shouldn't all the drains be identical? Pretty sure I'm right about that. In any event, this wrong resistor didn't change the behavior of the machine. There is a slight voltage coming through it. There was a voltage increase. So I'm still thinking that we took a little bit of power damage, and I think we have broken power circuit, so that's where we're at. But I need to rule out the CPU completely, and I need to obtain some more donor parts. So before I continue working on this, I'm gonna close up the video here. We're gonna leave this as so the diagnosis is this is absolutely thermal shutting off. I mean, I can't. There's no other explanation for what's happening, and that's what it looks like happening here. But on top of that, I don't think we're getting clean power all through this board. I'm gonna give myself a sanity check, make sure I'm testing my MOSFETs properly, because it has been a while. But I'm going to get some of the components that I'm going to need to work this circuit, and then come back to this machine down the road. There's no point. I need to rule out the easy fix first, and then we'll come back to this. And if it took some sort of power surge, the damage can be to the point where I'm not going to repair it. We could have dead chips everywhere. But I'm feeling pretty comfortable the fact that we've been able to mostly post that I am only dealing with a voltage control problem somewhere over here and thermal management problem over here, and they can absolutely be related. But I'm going to keep investigating this area because this is what's giving us change. So I'm going to grab some parts, button this up. My next stream, I have a machine coming that I am incredibly excited about, and I don't have to do any microelectronics on it. It is a 286 that I'm getting from our friends in Canada. I've never even I've never worked on a 286, so I'm actually pretty excited about it. No idea what shape it's in. I'm getting it basically as is, unknown condition, but visually it looked great. So that's my next big project, and I will sort out a lot of these bugs, and I won't have the vision problems with this. When I come back to this, I will have a solution for the audience and myself. I can't see shit, and I know you can't see anything either, so we're gonna solve that for everybody on the cheap. I have to do it on the cheap. But anyway, thanks for watching. We'll mark this as this is not a this isn't a thumbs up or down yet. I think we've got some power damage, and I think that's actually the primary concern. We have to solve that before we're gonna get anywhere anyway. So hope to see you again soon when that machine gets here. I don't know how long it takes to get things from up there, but we'll find out. Will do.